Press the bell icon on the YouTube app and never miss another update.
Before going to next topic, let us consider the curve y is equal to f of x. Y equal to f of x. For example, this is the curve y equal to f of x. Let capital P be the pointer on the curve y is equal to f of x and Q be another point or neighboring point of capital Q on the same curve. So in geometry, what I said, line segment means it is the line joining the 2 points. It is called a line segment. So therefore, let us join P and Q 2 points. Let us join P and Q. Then we are obtaining the chord PQ. Just like that. Okay. Right. This is PQ chord. This is the PQ chord of y is equal to f of x. Means the line joining the 2 points is called a chord. It is denoted by PQ chord. Later, for example, Q is here. For example, Q is here. Then the chord will becomes like that. The chord will becomes like that. Okay. The chord will becomes like that. Means what? If in the first case the length of the PQ chord is 10 units, then it will be reduced or something. For example, let us say 8 units. Later, if Q is here, then the chord will become like that. Means of course it has 6 units. Say like that. Means what? Gradually the length of the chord is diminished or it is decreased. Understand? So therefore here Q is what does it mean? What does it mean? Q is approaching. Q, capital Q is approaching to capital P along the same curve, At the same time, the length of the chord is diminished gradually. Understand? Next, later, for example, Q is here, then the chord will be reduced like that. Ultimately, in the last position, Q is coincide with capital P, just like that. Okay, just like that. So therefore, the final stage will be like that. Okay. So where is the Q? P is equal to Q indirectly. Means where is Q? Q is here. Where is P? P is itself. Means Q is coincide with capital P, just like that. Okay, understand? This is called limiting position. Limiting position of the chord PQ bar. Understand? So mathematically it is denoted by limiting position means LT. Q approaches to capital P, PQ bar. Understand? So this is called the tangent at capital P to the curve y is equal to f of x. This is the right definition. Means that as Q approaches to capital P, the limiting position of the chord will becomes the tangent at P to the curve y is equal to f of x. We see that or we can observe that for curve y is equal to f of x and for the line there will be only one point in common. Then it will become the tangent at capital P. Of course, tangent means it is a straight line. It is a straight line. Tangent is called the straight line. Okay. Another simple definition is there. Simple definition means, for example, y is equal to f of x is a given curve, and suppose capital L is equal to 0, one given line. If there exists only one point in common for both the straight line and the curve, then this line is called the tangent. This line is called the tangent at capital P to the curve y is equal to f of x. This is the simple definition of the tangent. Okay, next. Here y is equal to f of x is a curve, and this is capital P. It will be the tangent. It is the tangent at capital P. Here capital P is called, this is called the point of contact, the point of contact. Capital P is the point of contact. Whenever the straight line touches to the curve y is equal to f of x at capital P, that common point to both the curve and tangent is called point of contact. Next, for example, you see here. For example, this is another straight line which is perpendicular to tangent. Okay, it is also a straight line. Another straight line which is perpendicular to the tangent. Okay. Next, I will draw a particular straight line which is perpendicular to the tangent, just like that. So, this equation or this perpendicular line has one separate property. What is that? Means it is passing through point of contact. The other lines are not passing through the point of contact. Hence, this is the line which is perpendicular to, this is the line, perpendicular to tangent, and passing through point of contact is called the normal. It is called the normal equation, normal at capital P. So therefore this line is called tangent at P, and this line is called normal at P. Normal means perpendicular line. Understand? Perpendicular line, it is general word, but particular case is it is also passing through the point of contact. That's why it is said to be as the normal equation at capital P to the given curve y is equal to f of x. Okay, next you come here. Actually, we did know very well the different kinds of straight lines in 11th standard. So out of which we are very familiar with the parametric form of the straight line equation. Parametric form. Understand? 1 minute, you come here. Parametric form means y minus y1 divided by x minus x1, that is equal to tan theta. We have the parametric form. Understand? That is what y minus y1 divided by x minus x1, that is equal to tan theta. Okay. So on simplification or by taking cross multiplication, we are having y minus y1 is equal to something tan theta into x minus x1. So it is a straight line equation. Okay, because already I said tangent is a straight line. Straight line means what? Every first degree equation representing a straight line. Every first degree equation representing a straight line. So therefore, tangent equation always a first degree equation. Of course, we did know different forms of straight lines, out of which you can recall point slope form. Already another form is point slope form. Point slope form means what? Y minus y1 is equal to m into x minus x1. So you can recall this equation or parametric form y minus y1 divided by x minus x1, that is equal to tan theta. Okay. Let us consider this is also. So it can be written as y minus y1 divided by x minus x1, that is equal to m. Understand? In geometry, what I said, this is x-axis and this will be y-axis. For example, this is the line which is making an angle theta in the positive direction with the x-axis. Then theta is called inclination of the line. What is that? Inclination. This is the geometry. Inclination of the line. And tan theta is called the value of tan theta. Theta is called the inclination and the value tan theta is called slope. Slope of the line. Slope of the line. And it is denoted by simply m. So therefore, m equal to tan theta. This is the slope. So therefore, instead of m, we can write tan theta. That's what I wrote y minus y1 divided by x minus x1, or else y minus y1 is equal to tan theta into x minus x1. So therefore, or we can write y minus y1 is equal to m into x minus x1. Okay, right, 1 minute. What is the general equation of the straight line? General equation of the straight line, ax plus by plus c equal to 0, whereas either a not equal to 0 or b not equal to 0. Either a not equal to 0 or b not equal to 0. Then this is representing a first degree equation in terms of x or y or both. Then it is called the general form of the straight line. Okay, already we did know the differentiation of y with respect to x. Okay, according to geometry, its slope is equal to minus x quotient by y quotient, minus x quotient by y quotient. How? We have to reduce this equation in terms of y is equal to mx plus c. Shall I explain that one? Okay. For example, ax plus by plus c, that is equal to 0. Then by equal to minus ax plus minus c. So that implies y is equal to minus a by b into x plus minus c divided by b. Of course, to be understood that b is not at all equal to 0. So therefore, clearly we see that it is in the form of mx plus c, say capital C. Okay, whenever the equation representing as the form of y is equal to mx plus c or expressed in the form of y is equal to mx plus c, m stands for the slope. M stands for the slope, means x quotient is slope. Here x quotient is minus a by b. That's what I said already. M equal to minus means minus a by b, minus a by b. So therefore, the slope of the equation m is equal to minus a by b. So indirectly it is minus x coefficient divided by y coefficient. Understand? So therefore the slope of the line, general equation of the straight line, ax plus by plus c is equal to 0 is m equal to minus a by b. Okay, keep it up. Next, come to calculus. Ax plus by plus c is equal to 0, the given equation. Let us differentiate with respect to x. This is the simple representation. What I am telling that the first derivative is called the slope of the given curve. Understand? That is what I am telling in simple way. Listen. Differentiate with respect to x. Then a plus b into differentiation of y means y dash plus 0, that is equal to 0. This is called differentiation with respect to x. Okay, if possible I will write differentiate with respect to x on both sides. Then we are getting like that. So that implies b into y dash equal to minus a. So y dash equal to minus a by b. You come here. Minus a by b. Minus a by b. It is what? Minus a by b. So therefore y dash equal to m. So my intention is to showing that m is first derivative. Slope means first derivative. So therefore slope that is equal to tan theta here. Tan theta. Slope geometry. Tan theta. Trigonometry. Next we proved that y dash minus a by b means what? Dy by dx. So therefore this is geometry language, this is trigonometry language, this is calculus language. So therefore I proved that the first derivative is the slope of the line. So you come back here. This is what? Tangent. Actually tangent at P, tangent at suppose capital P of x1 y1. Now I am writing the tangent equation at P of x1 y1 to the curve y is equal to f of x. We are defining like that y minus y1 is equal to actually m into x minus x1. Tangent is a straight line. Next here we proved that y minus y1 is equal means m means dy by dx. It is dy by dx into x minus x1, or we can write y minus y1 is equal to m into x minus x1, where m is equal to first derivative of y with respect to x at the given point p of x1 y1. Actually dy by dx is also called as gradient of the curve. Actually this dy by dx, it is called gradient. The gradient of y is equal to f of x. But at the given point p of x1 by 1, the first derivative is called the slope. So therefore anyhow this is the equation to the tangent. Y minus y1 is equal to m into x minus x1, whereas m equal to dy by dx at the point capital P of x1 y1. So therefore the tangent at capital P of x1 y1 to the curve y is equal to f of x is y minus y1 equal to m into x minus x1. So therefore whereas m equal to dy by dx at the given point capital P of x1 comma y1. This is the formula. Similarly we can write the normal at capital P of x1 comma y1 to the curve y equal to f of x is y minus y1 equal to normal means already we did know. For example, this is one line, its slope is m1. Another line is there, its slope is m2. For example, if these two are mutually perpendicular, then we can say that m1 into m2 equal to minus 1, geometrical property. Then we can write m1 equal to minus 1 by m2, or m2 is equal to minus 1 by m1, just like that. In the same sense, instead of m, we can write minus 1 by m, that is x minus x1. This is called the equation to the normal at capital P of x1 y1 to the curve y is equal to f of x. Actually, mostly we are having simple formulae. It is called tangent equation formula. This is called normal equation formula. Okay. Next, here you come here. For example, two curves are there. This is y is equal to f of x. Next, this is another curve y equal to something z of x. Let capital P and capital Q be the points of intersection of two curves of y is equal to f of x and y equal to z of x. Next, let us draw a tangent at capital P to the first curve f of x. Next, another tangent at the same point, draw a tangent to the second curve, means this is the tangent of z, this is the tangent of the curve f at capital P. So therefore, actually directly we cannot find the angle between the two curves. So for which we are taking two tangents at capital P to the different curves like that. Okay. Next, the angle between these two tangents is nothing but angle between the two curves. What I am telling that, for example, these two are the straight lines. Already we did know how to find the angle between the two straight lines. It is in 11th standard already explained. And okay, so what I am telling that the angle between the tangents drawn at capital P to the both curves is nothing but angle between the two curves, just like that. Understand? So therefore, the angle between two tangents at capital P to y equal to f of x and y equal to g of x is called as the angle between two curves at capital P. This is the definition of angle between the two curves. Okay. Next, actually, the angle at capital P may not be same as angle at capital Q. For example, let us take two parabolas. So this is x-axis, this is y-axis. This is the parabola. Y square is equal to 4ax. Next, another parabola, x square is equal to 4ay. This is x square is equal to 4ay. Understand? You come here. Actually, y-axis is the tangent to the parabola y square is equal to 4ax. Understand? Next, x-axis is the tangent to the parabola x square is equal to 4ay. So therefore, x-axis is tangent to x square is equal to 4ay. and y-axis is tangent to the parabola y square is equal to 4ax. So clearly we see that angle between them is 90 degrees, but it is not this. For example, theta, this theta is not at all equal to 90 degrees. So therefore, what I am telling that even if we are drawing the tangents just like here at Q, this angle, for example, it is theta 1, it may be theta 2. So therefore, theta 1 not at all equals to or may not be equal to theta 2. For example, this one, this diagram. Okay, right. Later, this is y equal to f of x. This is y is equal to this is the tangent of the curve y is equal to f of x. Let it be, its slope is m1. m1 means what? m1 is equal to simply f dash at the point capital P of x1 comma y1, x1 comma y1. Next you come here. This is the tangent. Its slope is m2. m2 means what? m2 means what? Z dash at the given point P of x1 comma y1. So clearly we are having m1 value and m2 value. Now we are telling some special properties. What is that? m1 is equal to m2. m1 is equal to m2 means what? Slopes are equal. Slopes are equal means these two tangents becomes like that. Means either they are parallel or will coincide. Means what? Tangents are parallel. Means tangents will be parallel. In such a case, then two curves will become like that. Means they will touch externally. Understand? So therefore m1 is equal to m2. That by implies y is equal to f of x and y equal to g of x will touch each other externally. It is to be understood. Next, m1 into m2 that is equal to minus 1. Product is minus 1. Means what? Tangents are mutually perpendicular. Then the diagram will become, this is 90 degrees. Okay, this is at capital P, 90 degrees. It is called curves cut at right angle. Means the angle between the two curves is 90 degrees, or we can say that curves cuts orthogonally, we can say like that. Understand? So therefore, simple. Tangent is a straight line. It is the first degree equation. Okay. Next, if there exists a point, only one point. If there exists only one point in common for the given curve and the given line, then it should be a tangent, and that common point, say capital P, is called a point of contact. Next definition: the line which is passing through point of contact and perpendicular to the tangent is called the normal. Next, one formula. The tangent at capital P to the curve y is equal to f of x equal to f of x, y minus y1 is equal to m into x minus x1. Already we did know this is the one of the kinds of formulae for a straight line, or in different forms of straight line. So once again, the tangent at capital P to the curve y is equal to f of x will be y minus y1 is equal to m into x minus x1, whereas m equal to dy by dx at the given point capital P of x1 y1. Actually, once again, for example, y is equal to f of x. Y dash, it is called gradient. It is called gradient of the curve y is equal to f of x. For this, if we are going to substitute p of x1 y1, then it is becoming the slope of the tangent. M means this is the slope of the tangent. Slope of the tangent. Okay, this is the gradient, this is the slope of the tangent, right? So therefore y minus y1 is equal to m into x minus x1. It is the formula for the tangent at the point P of x1 y1 to the curve y is equal to f of x, where m is equal to dy by dx at the given point. Similarly, normal equation y minus y1 is equal, minus means m, it's a reciprocal 1 by m. M means actually it is plus m, opposite sign minus. It is called the equation to the normal. Understand? Later, if capital P comma capital Q be the points of intersection of the two curves y is equal to f of x and y equal to g of x, then the angle between the two tangents at capital P is nothing but the angle between the two curves y equal to f of x and g of x. The angle at capital P may not be is equal to the angle at capital Q. For example, let us take two parabolas. Understand? Later, if m1 is equal to m2, then the curves will touch to each other externally. If m1 into m2 is equal to minus 1, then the curves cut at a right angle. In other words, the angle between the two curves is 90 degrees. In other words, the curves will cut orthogonally. So, this is the simple topic. Its application, exercise 6.3, NCERT textbook, 4th question. Find the slope of the tangent to the curve y is equal to f of x at the point whose x coordinate is 3. Means what? For example, y equal to something, this is given f of x is a curve. Next, actually it is the point of contact, and this is the tangent equation. So, for the point of contact, x coordinate is given just like that. So, find its slope. Find slope m. That's all. It is the question. Okay. Slope geometry m equal to, actually it is tan theta. So that is equal to dy by dx at the given point capital P of x comma x coordinate is what? 3. X coordinate is 3 comma y, need not to write like that. So therefore simply x coordinate is x is equal to 3, just like that, because f of x is a single variable function in terms of x. Okay, so that is equal to differentiation 3x square minus 3. So it is 0. So therefore put in this expression x equal to 3. So 3 into, put x equal to 3. 3 square minus 3, that is equal to 3 into 9 minus 3. So 3 common, 9 minus 1, that is equal to 3 into 8, that is equal to 24 something units. So this is the slope of tangent. Understand? Right. This question is over. Next, second question. Another question. Find a point. Finding the slope for the different curves. It is one type. Second model. Finding the points means P of x1 by 1. Okay. This is the, for example, it is y is equal to, I am not taking the perfect graph, just I am explaining, or I am taking estimation graph, general, okay, y is equal to f of x. 1 minute, you come here, this is the important. Find the point on the curve y is equal to something, means what? For example, this is point of contact, one tangent can be drawn like that, unit tangent. Next, what is the question? This tangent is parallel to the chord joining the 2 points 2, 0, 4, 4. Okay, put x equal to 4. 4 minus 2. 2 square 4. Y is equal to 4. Put x equal to 2. Okay, means what? For example, capital A 2, 0. Next, capital B, it is 4, 4. Let us join A, B, just like that. This chord, say this is point of contact, I will write there. This chord is parallel to tangent, just like that. Understand? Means what? AB slope M, then tangent slope is also M. In geometry, first year geometry means 11th standard. If the two lines are parallel, then the slopes are equal. Or if the slopes of two given equations is the same, then that equations are straight line equations are mutually parallel, just like that. So simply, if M1 is equal to M2, then that by implies the lines are parallel. Okay, right. So therefore, 1 minute. Slope of the chord. 1 minute. Slope of the chord means, for example, it is x1, y1. This will be x2, y2. Slope of the chord formula in geometry, y2 minus y1 divided by x2 minus x1. So y2 minus y1, 4 minus 0, 4 divided by 4 minus 2, 2. That is equal to 2. So that is equal to parallelism, means what? Dy by dx at the point, okay, at the point, say capital P. So therefore, that is imply 2 is equal to, what is that point? We don't know. Let it be x comma y at present. So therefore, dy by dx means it's a differentiation. 2 into x minus 2 whole power 2 minus 1 into dy by dx of x minus 2 is 1 minus 0, 1. Right. So 2 cancel. Then x minus 2, that is equal to 1. Then x equal to 3. 1 plus 2. X equal to 3. Okay. We obtained x equal to 3. Okay. So therefore we can write capital P of x coordinate 3, y coordinate we don't know. But capital P lies on the given curve y equal to x minus 2 whole square. Of course, capital P lies on a tangent as well as on the given curve. Understand? Because if there exists only one point in common for both the curve and the tangent or the straight line, then only it is said to be the tangent, then only it is said to be the point of contact. Already I explained everything in the synopsis. Okay, so that is equal to y. Therefore y is equal to, what is x? 3. 3 minus 2 whole square, that is equal to 1. 1 whole square is equal to 1. So therefore x value 3, y value 1. Therefore the point of contact is capital P of x value 3, y value 1. Understand? Right. Come to next question. Find the slope of the normal to the curve x equal to a cos cubed theta and y equal to means x equal to a cos cubed theta, y equal to a sin cubed theta at theta is equal to pi by 4. This is the question. about only finding the slope. So already we did know how to differentiate to parametric equations in the differentiation topic. Okay, so therefore first dy by dx is equal to this dy by d theta whole divided by dx by d theta. Okay, so that is equal to its derivative a into its derivative 3 into sine square theta into d by dx of sine cos theta whole divided by its differentiation a into differentiation d by d theta of cos cubed means 3 into cos square theta minus d by d theta of cos theta is minus sine theta. So simply a cancel, 3 cancel, okay, 1 sine cancel, 1 cos cancel. So it remains only minus sine theta divided by 1 cos theta, that is equal to minus tan theta. So it is only dy by dx. So therefore dy by dx is equal to minus tan theta. So therefore slope is equal to dy by dx. Actually this is the gradient of the curve. Slope, how can we are getting the slope m? It is at the given point. Know the difference. This is called gradient. Gradient of the curve. This is called slope of the curve. This is the slope m. Okay. So that is equal to minus tan pi by 4. That is equal to minus 1. Next, you come here. Next question. Find the points at which the tangent to the curve which is parallel to x-axis. Understand? 1 minute. This is the x-axis. Okay. Slope of x-axis. Slope of x-axis. X-axis is what? Tell me. 0. Already we did know in the 11th geometry. 2-dimensional geometry. Okay. Next, what is the question? 1 minute. For example, this is the given curve. This is the point of contact. Now I will draw the tangent. So this is the tangent, like that. Tangent. This is the tangent at capital P. Okay. This is y equal to f of x given curve. This is y equal to f of x. I am not telling this is the parabola. Just it is y is equal to f of x. For our convenient, mathematical convenient, I do like that. Okay. Don't say parabola. Understand? Right. This is the curve. Okay. Point. What is the question? Find this point of contact. Right. 1 minute. First, I will find the gradient. Means y dash equal to y is a function of x. Therefore, y dash means differentiation with respect to x. So this is 3x square minus 6x minus 9. This is y dash. Okay. Of course, it is therefore m is equal to what is p coordinates? We don't know. That's why letter x comma y general point, or you can say x1 y1, or you can say x0 y0, or you can say alpha comma beta, just like that. It is your choice. You can take any letter. So I took just x comma y. So m is equal. It is the gradient. Already I said here. It is first derivative is called the gradient. Slope. How can we find the slope? How can we find the slope m? By substituting given values, it became the slope. Right. Okay. M is equal to y dash at the given point, capital P of x comma y. It is means instead of x put x same. So that is equal to x square minus 6x minus 9. Okay. 1 minute. The slope of x-axis. The slope of x-axis. The slope of x-axis is 0. Not only slope of x-axis, but also the slope of every horizontal line, I will write here, slope of horizontal line, the slope of horizontal line is 0. Slope of y-axis is what? Infinity, not defined. Or the slope of vertical line is what? Not defined, infinity, just like that. Okay, later we discuss. Slope of x-axis is 0. So therefore, these two are parallel. Parallel means its slope is same as its slope. Okay. So therefore, m equal to 0. 0. M is what? 3x square minus 6x minus 9 equal to 0. Alright, this is called the solution of quadratic equation. So that implies it is x square minus 2x minus 3, that is equal to 0. So therefore, x square minus it is 3x plus x minus 3, that is equal to 0. So x into x minus 3 plus 1 into x minus 3, that is equal to 0. So x minus 3 into x plus 1, that is equal to 0. So that implies x equal to either 3 or minus 1. So 1 minute. It is what? Y is equal to f of x. This is the given curve. Where is point of contact? This is point of contact. This is point of contact. Remember once again, P lies on the given curve and the tangent. P is satisfying to both equations. Understand? Right. So therefore, but capital P lies on. Let it be equation number 1. Lies on equation number 1. Equation number 1. So first case 1. What is that? Case 1. X equal to 3. So therefore, in this case, y is equal to, the given curve is x cubed minus 3 x square minus 9x plus 7. That is equal to 3 cubed minus 3 into 3 square minus 9 into 3 plus 7. That is equal to, it is 27. Okay, we can take 3 square common there. It is 3 minus 3 square common 3 minus 3, 0. Okay, anyhow, it is 0. Next to minus 27 plus 7, that is equal to minus 20. So, in the case of x equal to 3, y value minus 20. So therefore x equal to 3, that implies y equal to minus 20. Right. This is about first case. Okay. 1 minute. Therefore, I can write like that. Therefore, capital P 3 comma minus 20. Capital P of 3 comma minus 20. Remember once again, this point capital P of 3 comma minus 20 means what? X value 3, y value minus 20 will satisfy not only the given curve but also the tangent. Understand? But the question is about only the point. Therefore, this is the answer. Let us case 2. Case 2. X equal to minus 1. So then y is equal to x cubed. So minus 1 whole cubed minus 3 into minus 1 whole square. 3 into minus 1 whole square minus 9 into minus 1 plus 7 plus 7. So therefore y equal to minus 1 minus 3 plus 9 plus 7. So 9 minus 4, 5. 5 plus 7, 12. So therefore capital P is x minus 1 comma, y value 12. Understand? Here, the tangent is not given. That's why we need not to verify whether the point capital P is again satisfying the given tangent or not. It is not necessary here because this tangent is not given. Just he said find the points so that the condition tangent is parallel to x-axis. Once again, this is the given curve y is equal to f of x. This is the tangent at capital P. We have to find the coordinates of capital P. That's why we assumed x comma y. We are finding the gradient of the curve means dy by dx. Later it is parallel to x-axis, but x-axis slope is 0. Therefore, this m is equal to 0. M gradient is this one. From this equation, we are going to find x values. After that, substituting for y. This is the problem. Of course, it is the important model. Hence the problem. Next.